For this video, I'd like to talk about the concept of square roots and how to calculate them. So right here we have the example, the square root of 16, and what this is essentially asking us is what number multiplied by itself gives you 16. And another way you can think about this is that it's some number squared that's equal to 16. Though I should mention that we're just looking for the positive number that when multiplied by itself gives you 16. When you have it written in this notation with this square root symbol, this means the principal square root, or it's essentially asking what is the positive number that when multiplied by itself gives you 16. So in this case, x would be equal to 4, since we know that 4 times 4 gives you 16. So in other words, the square root of 16 is simply equal to 4. So let's try a couple more examples. So let's say we have the square root of 36. So again, this is what number multiplied by itself gives you 36. And like I said above, we're looking for the positive number that when multiplied by itself gives you 36. So in this case, if we multiply 6 times 6, we get 36. So the square root of 36 is simply equal to 6. And if we do one more example like this, let's say we have the square root of 81. So what number multiplied by itself gives you 81? And in this case, it would be 9. So 9 times 9 is equal to 81. And while it is true that minus 9 times minus 9 also gives you 81, with this notation, this square root symbol, this is just looking for the positive version. So in this case, we are not concerned with the fact that negative 9 times negative 9 would also give you 81. So the square root, or we could say it the principal square root of 81 would be 9. And at this point, you might be wondering, how do you take a square root of a number like 2? Since there are no whole numbers that, when multiplied by themselves, give you 2. And in fact, if you throw this into the calculator, the square root of 2 would be something like 1.414, and then its decimals would just go on forever. This is what we call an irrational number. Or essentially, this cannot be written as some sort of fraction where a and b are just whole numbers. So that's essentially what it means to be irrational, that we can't write this as a fraction. And the same would be true for, let's say, the square root of 3. This is something like 1.73, and then that as well goes on forever without a pattern. The square root of 3 also can't be written as a fraction. And in fact, pretty much all of the square roots can't be written as fraction, and so they're going to have these infinitely long decimals that don't have a pattern. So the square root of 5, the square root of 6, the square root of 7, and so on, all would have infinitely long decimals, but something like the square root of 9 we know is just 3 times 3. So some of them do have whole number answers, when whatever is under the square root is what we call a perfect square. And in general, if you have some number, let's say 5 squared, essentially the square root and the square cancel each other out so that you're left with just the number that you started with on the inside. So in this case, 5. And you can see this is true since 5 squared is just 25, and we can ask ourselves what number multiplied by itself gives you 25, and that would just be 5. And this idea would work with essentially any number you can use as the base. Like let's say we had the square root of 11 squared. And my claim is that this is equal to 11, that the square root and the square just cancel each other out. But you can see this is true since 11 squared is just 121, and the square root of 121 asks us what number multiplied by itself gives you 121, and that would be 11. And you can generalize this and say that as long as you have some positive number x, that when you take the square root of x squared, the square root and the square cancel, and you're just left with x. And you might also be wondering, how do you actually calculate the square root of one of these irrational numbers here? Like the square root of 2, we know from putting it into the calculator that you'll get 1.414, and then so on. But you might be wondering, how do you actually calculate this by hand? And there are ways to calculate it, but those methods tend to be fairly tedious and will not be covered in this video.